I am Lieutenant Colonel Schmidt from the Bomber Section of the Directorate of Aerospace Safety at Norton Air Force Base, California. You are about to see and hear a most unusual story about the aircraft you fly, a story that has made aviation history. We at the Directorate of Aerospace Safety believe the factors of this incident will increase your understanding of B-52 flight characteristics and heighten your appreciation of its capabilities. The aircraft involved was a B-52H on loan to the Boeing Company. Its flight crew members were Mr. Charles Fisher, instructor pilot, Mr. Richard Curry, pilot, Mr. Leo Coors, co-pilot, and Mr. James Pittman, navigator. Here to tell you this remarkable story firsthand is one of the Boeing pilots who was at the controls, Mr. Richard Curry. Dick?
Thank you, Colonel Smith. Our mission was to conduct a flight load survey to obtain and record the structural loads encountered on a routine low-level sortie. Special instruments were installed in the cockpit to record the stresses exerted on various parts of the aircraft. An 8-hour flight was scheduled along a route running from Wichita, Kansas, southwest to the Rocky Mountains. The mission called for 10-minute runs at 280, 350, and 400 knots calibrated airspeed at 500 feet above the ground, utilizing the low-level mode of the autopilot. The initial portion of the flight progressed as planned, with only light turbulence encountered at the end of the 6th leg. However, as the aircraft turned north in the vicinity of Wagon Mound, New Mexico, and began a course parallel to the mountains, the instruments, identified here in orange, began indicating increasing turbulence and heavy gust loads on the tail section. We elected to discontinue the low-level portion of the flight, and the aircraft was climbed to 14,300 feet mean sea level, where the air was relatively smooth. We then decided to continue the mission using the next speed schedule of 350 knots. Since the terrain elevation was steadily increasing, the aircraft flight path was approximately 1,000 feet above and slightly to the right of East Spanish Peak near Aguilar, Colorado. Wind at this time indicated 62 knots west component, but no turbulence was noted. Then at 345 knots, while accelerating to 350 knots, an area of extreme turbulence was encountered. It lasted approximately 9 seconds. With this model, I will attempt to show you approximately what happened to the aircraft when it was struck by this turbulence. The turbulence came in rapid, explosive-like gusts. The airplane was pitched up and yawed to the left, followed immediately by a very rapid yaw to the right and a resultant right rolling moment. This motion was opposed with approximately 80% left wheel authority. A high-frequency vibration was felt in the rudder pedals, and rudder pedal displacement gave no response. The elevator response was also very poor. The crew was alerted to prepare to abandon the aircraft. However, we soon realized that the aircraft still had marginal control. At this time, the air brakes were raised to position 1 to improve longitudinal stability, and a fuel transfer was started to maintain a forward center of gravity. Lateral control was aided by very small asymmetric power settings, which helped maintain the aircraft in a side-slipping flight attitude. After the aircraft was brought under marginal control, we called for assistance. The first to arrive was a Boeing Bail F-100. This is what the pilots saw. Approximately 83% of the vertical fin had been ripped away. We immediately set a course for Wichita, Kansas, and developed our flight strategy. Boeing Flight Test had already recommended that the aft main gear be lowered, as this would be a stabilizing factor in the absence of the vertical fin. Any drag after the center of gravity would tend to stabilize the aircraft. Here, the outboard air brakes are at position 4, which is also an area after the center of gravity. Here, our airspeed is about 210 knots indicated, which is about 30 knots above the minimum recommended for this weight with flaps up. Small excursions up to 220 and down to 200 knots were made. However, 210 knots was found to be most satisfactory. At this time, the altitude was approximately 12,000 feet mean sea level. The center of gravity was calculated to be about 19%, with the vertical fin missing. The weight of the vertical fin is estimated to be about 2,000 pounds. Due to the reports of unfavorable weather at Wichita, it was finally decided to divert us to Blytheville Air Force Base, Arkansas, where surface winds were more favorable. While in the Blytheville area, making preparations for landing, we were advised to extend the tip protection gears first. Then the forward trucks were lowered. A yawing oscillation occurred during forward gear extension. However, this ceased when the gear reached a down and lock indication. We reduced airspeed to 160 knots at 10,000 feet and prepared for a long, flat final approach, hoping to be able to flare and touch down at the same speed. 160 knots flaps up approach speed was selected in order to obtain optimum body angle. We had computed a no-drag chute stopping distance of 5,000 feet. Here is the aircraft on final approach. 160 knots, outboard air brakes at position 4. All engines are near idle. Crossing the threshold, still at 160 knots, the aircraft started a slight left drift, and we decided not to hold off any longer, but put it on the runway. At touchdown, all air brakes were raised to position 6. We elected to use the drag chute, but decelerated to 130 knots before deploying it. We considered the possibility of a go-around, and had it been necessary, we would have used outboard air brakes at number 6 position. This is the B-52 at Blytheville Air Force Base shortly after landing. This aircraft was flown 5 hours in this configuration from the scene of the incident over Colorado to Wichita and then to Blytheville Air Force Base, Arkansas. A portion of the aircraft's original mission was to record the gust loads found in moderate turbulence. However, the loads we encountered were much greater than had been anticipated. An analysis of the recorded information revealed gust loads of a greater magnitude than had ever previously been recorded on any large aircraft. Well, Colonel, I guess that about sums it up.
Thank you, Dick. We at the Directorate of Aerospace Safety are indeed grateful to you for bringing us this first-hand report. A review of the data collected on this flight indicates that the airframe design criteria for future heavy aircraft should be reevaluated and possibly revised for future aircraft design. An engineering change to incorporate additional strength in the B-52 empennage is well underway at Wichita. In conclusion, let us review the things which enabled this aircrew to return this aircraft to a safe landing. Excellent crew coordination to regain positive control of the aircraft. A call for chase aircraft. A call for expert technical assistance. Reduction of airspeed to 30 knots above minimum recommended, flaps up. Proper use of air brake settings with inboard air brake circuit breakers pulled. Transfer of fuel for better aircraft stability. Extension of the aft main gear only for directional stability, and judicious use of throttles for desired power settings for optimum controllability. We salute this Boeing flight test crew for a fine job of airmanship. By bringing this aircraft back, they have supplied the Air Force with invaluable data on the gust load velocities that are often imposed on large aircraft flying low-level missions. Salutes also to the other agencies and the Boeing Company for their excellent cooperation.